Dear students, in this video we'll start with Module 4, the first chapter, the classes and objects. Till now we have used the Python built-in types of int, float, string, list, dictionary, all these built-in classes we have discussed so far. So in this video we'll discuss with what are the user-defined types and why it is required. So if for example, we consider the concept of a mathematical point representation. So in 2 dimensions, a point is a number where it is having 2 coordinates and treated collectively as a single object. How we are going to mark that coordinates? For example, if we are marking the coordinates of an origin, we write 0, 0. So other than any coordinates, how we are going to represent with the 2 different values in the x direction and in the y direction? What are those 2 values separated with a comma? We are going to mention this x units to the right and y units up from the origin. We are going to measure. So we know how to mark the coordinates of any point in the plane. So how we are going to represent this in a Python? So far what we have discussed is we have 2 coordinates. These coordinates can be a floating value. So if you want to represent this in a Python, we try to use the concepts which we have learned so far. So we feel like either we can use a list or a tuple. This will give the best choice in few cases, but not always. What is an alternative solution for this problem is class. So what is this class is? The class is an user-defined compound type. So how we can declare or how we can define a class? The class defines looks like this. We use the keyword class and the name of the class, and we need to write the set of things what is required in that class. For example, we don't want anything to be written in the class right now, then it can't be an empty, it has to be used with the keyword pass inside that. What is the syntax to write the class? Just what we have learned so far, the block or the compound statements can be started with a colon to the end of it, and then the set of statements followed with the indentation can be written. The same syntax followed in the class as well. Where I can write this definition in the Python program. So it can be written anywhere in the script, preferably. We'll start at the beginning. Members of this type are called the instances of the type or objects. When we are creating a members of this, we call that as an instance or as an objects. Creating a new instance is called instantiation. To instantiate a point object, we call a function point. This is a sample example how we do that. The variable blank is assigned a reference to a new point object. The function point that creates a new object is called a constructor. You have already learned what is a constructor in your object-oriented concepts. So we'll be discussing little more in this. In the next chapter, what is a constructor, how to invoke a constructor. Attributes or data. New data or attribute can be added to an instance using a dot notation. Here is an example. The blank dot x will be assigned with the value 3, and for the y coordinate we are assigning the value 4. This syntax is similar to the syntax for selecting a variable from the module. We already know how we access the variables from the module. The name of the module dot the name of the variable which we are accessing. These named items are called the attributes. So here is a syntactical representation of the attributes, how it works. The blank is a variable. This x and y are the attributes. So we are going to assign the values, the x and y are the instances. We are going to assign the values for those instances. So these are called the attributes. How we can print the blank? When we are just printing a blank, we are not able to access any values associated with it. It just prints what is this object is, where it has been created, and what type it is. The result indicates here, you can just see the details in this. The blank is an instance of the point class and it was defined in the main. So this hexadecimal value is a unique identifier for this object. So before discussing how to access the values, we'll just quickly discuss all the things what we discussed so far with, or we'll just have a glance of it. How to create a class point. So we have created here, since we are not writing any statements, we just written pass. We'll just execute this. So here we are creating an object for the class point. So once we create it, we are assigning the values for those instances. We know how to assign the variable name dot the member and the value will be assigned. So this 3 and 4 will be assigned for those members of the class. How we can print? When we print the blank, we know what we are going to print, not the values. We just print where it is and what is the unique ID assigned with that blank. So it's an hexadecimal value, or the what I can call this as an address which has been reserved for this variable or the object of the class point. So how we can print the values associated with that object? So blank dot the member, these are the two coordinates x and y, the points which we need to print. This is how we can able to print the members of the class. So you know what is this? It goes to the object blank and access the value of x and go to the object blank, access the value of y. So that is how we can print the values of x and y. So we can also modify the values which already hold in it. And so we access those values and do the computations. Here is a sample or simple script where we are just printing the value of x and y, and also we are printing this value of x and y square and add it together and we get those values. Even this is valid. You know what is the attribute, the difference between the attribute x and the variable x. So the next topic is instances as arguments. In this example, we are discussing how we can pass these instances as an arguments to the any function. So we create a class of point and we create an object for that class, and these are the two attributes of the point class x and y. Here we are just calling the function print point by passing p. P we know it's an object of that class point. So just the instances can be passed in the normal way, how we pass the normal variables into the functions, and we are accessing the members or the attributes of that object and we are printing the details in this. Next we discuss what is sameness. The meaning of the word same seems to be perfectly not clear until you give it some thought. For example, Ramu and Sham have the same car. What is the meaning of the same in this statement? And just have a look. One more statement. Bhamu and Mamu have the same mother. The sameness in both the statements are not giving the same meaning. In this, the Ramu and Shamu have the same car. They might be having the car of the same make and model. But the second statement, Bhamu and Mamu have the same mother. Here the sameness talking about it's a same person or a single person, what I can say. The idea of sameness is different depending on the context. The sameness of objects we'll discuss. On object there is a similar ambiguity. So to find out If two references referring to the same object, we use a double equals. Here is a sample example. We'll go through this. We are creating an object for the point with a P1 and we are assigned two different attributes for this P1, the 3 and 4. It's having the values 3, 4, x and y having the values 3, 4. So and we create one more object P2 and we assign the same coordinate values for this attribute as well, 3, 4. But when we are using an equality operator between these two objects to find whether these two are same, but basically these two are two different objects. Of course, they might be having the same coordinate values, but they are not the same objects. We get the result as false. What if you want both should have a same value? So then this is not the way how we create the objects. What we can just do it, copy the reference of one object to another object, then we can call these two are of same objects. So how we check the equality? There are two different types to check the equality, that are the shallow equality or the deep equality. Here we have an example for the shallow equality. What is this shallow equality is? So we have two variables P1 and P2. We have created of type point and we assign the values into it and we are just checking the equality here. Just see, we create a point P1 and we assign the values for the P1, 3 and 4. We just create one more object P2 of type point. Now we are not assigning any values for P2. Instead, we are equating the values of P1 into P2. Whatever is there in P1, we just passing the reference to the P2. When we just check this equality, the result will be true because P1 and P2 are pointing to the same location or having the same address, what we can see. So what if it is a deep equality? Here we are going to check whether these two objects having the same attributes. So here is an example for the deep equality. So I've written a function because there is a methods as well to check the or to do the deep copy. So we are not for the deep equality. To check the equality we use a double equals, but if you want to check the deep equality, like each attribute is matching with each other, then we need to write our own function or the method, what we can say. So here it's talking about deep equality. We have written a function same point. It receives two objects and checks each attribute based on the function or the class which we created. So the first attribute of the P1 and the first attribute of the P2, if these two match, and the second attribute of P1 and the second attribute of P2 if matches. If both of these matches, then it returns the result either true or false. Based on this result, we'll tell that these two objects are matching. So here we create an objects P1 and P2. We assign the value for P1 and assign the value for P2 and we invoke the function by passing these two objects into the function. So in this we get the result true. Here it's matching one by one with all the attributes of P1 and P2. This is called a deep equality. In the earlier one, it just matches if both P1 and P2 having the same reference. We're just talking only with in case of reference. We are not bothering about the attributes in this case. This is called shallow equality. So if both the objects having the same reference, it will be matching with both the shallow equality and the deep equality. In this video, we discussed what is a class, how to create a class, how to create an object of the class, and what are the attributes, what is the meaning of sameness, and we also discussed with how to do the equality between the objects, shallow equality and deep equality. With this, I'm winding up the session. In the next session, we'll continue with the remaining topics. Thank you for learning.